Okay, so what we're going to look at today is domain and range and a couple of other characteristics. So the first thing we're going to talk about is domain. And by definition, it's all possible x values or inputs of a function. And so when we look at it graphically, we are looking at the horizontal axis, and we are looking at our graph from the left side to the right side. And so we always start at the left because it's the smaller value, and we always end at the right because it is a bigger value. So then if we look at range, it's almost the same concept, except for it's the y values and it's the outputs of the function, and we look at the range from the bottom of the function to the top of the function. And so when we write about the domain and range, we're going to use this fancy thing called interval notation. And so for each continuous section of a graph, we're going to write the starting and ending point separated by a comma. So if we're looking at domain, we're looking at the starting point on the left and the ending point on the right. If we're looking at range, we're looking at the starting point on the bottom and the ending point on the top. Some functions we're going to look at are going to have arrows on either side or both sides, and that means that the graph is going to approach infinity. It goes off of the page. And so when we use interval notation, when we use infinity, we always use parentheses. And then you've got brackets to choose from, and that's when that number or value is contained within the graph. And so that's a solid point on the graph. So here are some examples down here. So this one, we've got brackets, which means it would exist at 2 and 4. We've got one bracket and one parenthesis. It would exist at 5, but it would be an open circle at 74. This means on the left side, we've got an arrow because it's going to negative infinity. And notice we've got parentheses there. We've got parentheses on both sides, so we've probably got open circles on both sides. And then here we've got this union symbol in between, which means that we just have two pieces of the graph, and somehow at 4 the graph breaks or is not continuous, or there's a hole, or there's just some sort of something that's there and we can't include it in the interval. So if we practice with this a little, we're going to use, so online, if you want to click and drag these lines, you can. I'm obviously not online. So we're going to look at domain and range. So domain is left to right. So what we're going to do is we are going to box in our function. So the left side, I'm going to draw a vertical line where my graph starts. And on the right side, I'm going to draw a vertical line where my graph ends. Since it is a solid point, my x value on the left would be a 1. My x value on the right would be a 10. So I write it in interval notation from 1 to 10. That function exists only in those x values. And then the range, if I go bottom to top, bottom to top, the bottom of my function, that y value is -2. The top of my function is 6. So we'll have range from -2 until 6. Now, if we look at the next one, we've got a lightning bolt. We're going to do the same thing. So we'll do domain. So the left of my function here, what x value does that cross at? Looks like a -5. Looks like it goes to +5. And we're just drawing these lines so that we have a visual representation. So we'll go from -5 to 5. And then the range is bottom to top. So the bottom of my function, that y value would be a -3, and the top would be a 7. And so you can pause your video here and see if you can do the next two. If you've attempted, we'll go ahead and check. So domain, from left to right, we've got -9 to 10 within our brackets. And then the range is bottom to top, y values. Still in brackets because my graph is existing there. There's no open circles. So my range will go from -8 until 2. And just remember that the smallest value goes on the left side. So then we've got a heart here. And we'll look at the domain and range. So domain is left to right. So it looks like we go from -6 until 3. So the x values. And my range is bottom to top. So we'll go from 0 until 8. So that's your domain and range really quickly. In Math 2, we are not going to spend a whole lot of time looking at graphs that look like this. They're just going to be a shape on a graph. What we're going to look at are actual functions. And so we're going to transition just a little bit to be talking about functions. Your functions are typically going to have an arrow on one side or the other. So if we were in class, I would show you a clip about Toy Story because Buzz Lightyear is known to say to infinity and beyond. And so remember that infinity, we can never reach it. If you think about a number line, if you've got 0 in the middle, to the left, if we go on forever, we get to negative infinity, and we don't really get there, but that's what we're approaching. And on the right side, we're approaching positive infinity. And so in interval notation, remember we're going to use parentheses because we never actually get to those infinities. Closed points, we're going to use brackets. Open points, we're going to use parentheses. If there's an arrow, that means infinity, and we're going to use parentheses there as well. So we're also going to throw in x and y intercept just to get a little extra practice. X-intercepts cross the x-axis, y-intercepts cross the y-axis. And all we're going to do is guesstimate where it's at given these graphs. So I'm going to keep drawing my lines. If you can see it without them, that's totally okay. But just so you got that extra visual, I'm going to continue to draw. So domain is left to right. I've got one open circle on the left and one closed circle on the right. So that means my domain, on the left I've got a -1, and on the right I've got a 3. On the left I have an open circle, so I'll use parentheses. On the right I've got a closed circle, I'll use a bracket. That notation is really, really important. And then we'll do range. Bottom to top. The bottom of my function is -4, and it's a closed circle, so we'll have brackets. And the top of the function is a +4, and it will have a parenthesis because it's an open circle. Then we've got an x-intercept, and these we're going to write as a coordinate point. So even though it looks like interval notation, know that x and y-intercepts we're actually naming the specific location. And then y-intercept, we've got it at 0, 2. So we'll look at several more examples. By the time you get through all these examples, you're going to want to bang your head on the wall because we've done it so many times and it's so easy by the end. So here we've got a function. The left side and the right side both have open circles. It's a piece of a parabola. And so we're going to use parentheses on both sides, and we'll have domain from -2 to +2 with parentheses. Range is bottom to top. The bottom of my function, that y value is 0. The y value on the top is 4. The 0 is going to be a bracket, and the 4 is going to be parentheses. X-intercept, so where it touches or crosses that x-axis, actually at the origin, so it would be 0, 0. And same thing for y-intercept. All right, here we've got a piece of a cubic function, it looks like. And so we'll identify domain is left to right, x values. So it crosses my vertical lines that I draw in, cross at -5 and 5. And -5 is a closed circle, so I'll use a bracket. 5 is an open circle, so I will use parentheses. Range is bottom to top, and so we've got -3 until 2. -3 has a closed circle, and 2 has an open circle, so we use parentheses. And then we've got our x and y intercept. So my x-intercept would be on the x-axis. It's somewhere between 0 and 1. So we'll just kind of guesstimate. We'll say about 0.2. And then my y-intercept, I think it's close enough to say -1. So we'll say y-intercept at 0, -1. Okay, so we'll do a couple more. We'll look here, changing our graphs just a little bit. Actually, we'll go here. There's extra examples online if you want to check your Canvas for that. So if we look here, we've got a different kind of function. It goes all over the place pretty much, but we're still going to be doing the same thing. We're going to go from the left side to the right side. There's no open circles, so we assume that those are closed circles. So my domain is going to be bracket -5 until 3. My range, the bottom of my function is -2. Be careful because you might accidentally think this is the bottom, and then you start drawing your line. You're like, oop, there's more over there. So just be careful there. And so the bottom of my function is -2. The top of my function is 4, and those should be brackets. X-intercept, we've actually got multiple. So we've got 1 here, 1 here, and 1 here. So we've got 1 at -4. We've got another between 1 and 2. Oh, I'm going to run out of room. We've got another one at like 2.4. And then my y-intercept is somewhere between 1 and 2, so we'll say like 1.80. Give or take. Those don't have to be exact. In the next example, what happens is that we now have an arrow. And with that arrow, that means we're dealing with infinity. And I'm still going to draw my lines to box in my function. But I'm just going to kind of keep in my back pocket, oh, that left side has an arrow. That means it's going to be going towards one of the infinities. And so since it's going to the left, we know it's getting more and more negative. We're getting smaller and smaller and smaller. You'd be in a lot of debt, if you want to think about it that way. So my domain, we're going to say, is from -infinity all the way until 2. And we'll say there's a closed circle at 2. There's no open circle. Okay, so range is bottom to top, so the bottom of my function and the top of my function. So the top of my function has that arrow, so I know it's going to be one of the infinities. So the bottom of my function is at 0. And the top of my function, well, this arrow means my graph is going to be going this way. And it gradually is getting taller and taller and taller. The height of the graph is getting bigger. So we'll go from 0 to infinity. X-intercept at 2, 0, and y-intercept between 1 and 2, so we'll say about 1.5. Remember that with x-intercepts, the y is 0, and with y-intercepts, the x is 0, so those are opposite of each other. It's really easy to mix up. All right, in this one, we're going to do the same thing, so we'll do our left side, and then our right side, and the left side of my function has a closed circle, so we'll be from -2 until this right side has an arrow, and it's going to the right, so we know it's getting bigger and bigger, so infinity. And then my range is bottom to top. Oops. And so the bottom of my function is 0. And the top of my function has an arrow. It's getting bigger and bigger and bigger. So we go to infinity. This is actually a piece of an absolute value function. They'll talk a lot about those in Math 3. And we've got some x-intercepts. We've got 1 right here at -1. And we've got a y-intercept at +1. So we'll look at a few more functions. 3 to be exact. We're going to do the same thing. If at this point in time that you are able to figure out your domain and range without drawing your lines, go for it. I'm going to continue to draw my lines just so we've got that extra visual. The domain, so the left side I've got an arrow, so I know it's going to approach one of the infinities. Since it is pointed to the left, it goes towards negative infinity. And then on my right side goes until 2. Range is bottom to top. Make sure we get the actual bottom of the function. The bottom has an actual point at 0, and the top has an arrow. So we know the range is going to be 0 to infinity. X-intercepts would be at 1, 0. Touches the x-axis there. And then we'll say the y-intercept is at 0, 1. All right. Same thing here. What happens is now we have an arrow on both sides of my function. This is a parabola. It's a quadratic. We'll spend a lot of time with quadratics. And so this left side has an arrow, so we know it reaches one of the infinities. Since it's on the left, we know it's getting more and more negative. So the left side of my domain is negative infinity. And the right side also has an arrow, so it goes towards positive infinity. And so another way people write these is all real numbers. So keep that in mind. And then range, the bottom of my function, I'm going to draw a line, even though I know that those arrows mean that it continues forever. Bottom of my function, they're going in the negative direction. They're both going down. It does not have an actual starting point, but I know that eventually we'll just start at negative infinity. It's really, really negative. And then the function continues up to the top, and it stops when your y value is 2. Remember, range is y, domain is x. We actually have 2 x-intercepts where it crosses the x-axis. And so we'll have a negative, maybe 1/2, and a positive 2.5. And then my y-intercept is 0, 1 again. Only crosses once. The last example for domain and range, we've got another piece of an absolute value function. And so we'll go ahead and draw our domain and range. This one's a little bit tricky. So domain, the left side of my function is -4. And the right side of my function, since I have an arrow, we know it goes to one of the infinities. Since it's on the right side, it goes to positive. My range, before you draw your lines, be really, really careful. So the top is pretty finite. We know exactly where it stops. But on the bottom, one side has a point and the other side has an arrow. So logically, if you think about this one, since we have that arrow extends the graph past this point over here. So I'm going to draw my bottom of the function with the arrow. And hopefully that will help me remember that it doesn't stop there. And so my range is going to be negative infinity until 0. I have one x-intercept at -1, 0, and one y-intercept at 0, -2. So that's a couple of examples about domain and range.